Well, hello. We're going to keep working on our adventure through exponents, and today this lesson might blow your mind a little bit, but be patient with you, yourself, with me, and I think you're going to be able to wrap your head around it. I think you'll be able to get this. Just give it a little bit because these things do look a little interesting. Um, and they look crazy, but once we wrap our head around it, I think you'll be fine. So exponents can be expressed as fractions. They can be. And so let's look at what that actually means. Okay, so we already know that one of relationships between exponents and radicals. Okay, so this is something that's a little interesting. So let's look at this guy right here. So this is saying 2 to the third power, and instead of square rooted, because that's what that means, that's square root, and we don't write the 2 in there for that. This is like a cube root. Okay, so let's look what that looks like. The cube root of 2 to the third power, so that's 2 times 2 times 2. So 2 times 2 times 2 is 8. So I'm asking myself, the cube root. Now the square root is asking me what times what gets me the number. So cube root is asking me what times what gets me the number. So the cube root of 8, what times what gets me 8, ends up being 2 itself. So what this is saying here, this whole thing is saying that if you have your index here and you have your exponent, if they match, you're going to end up with the base number itself. They kind of cancel each other out. They kind of unroot the whole thing. So that would mean the quad root of 3 to the fourth power, the base stays the same. This would be true as if I had like 7 to the fifth power and I was asking for, like, this is an index, so the index of 5. Well, that's going to equal 7. So it kind of undoes itself, if that's a word. Okay, so now that we have that, or we're kind of slowly wrapping our head around that, let's move over to what's going on here. Okay, there can be another relationship which is going to be in different computation and help it be a much simpler. I think it's a little bit complex, but let's connect everything. So the square root of 2 is equal to 2 to the half power. 4 squared is equal to 4 to the half power, which equals 2. Huh. That's interesting. Okay, so for the square, or second root, we can write it as half the power. That's what's really happening here. The square root is half the power. So let's look at some more of those. Okay, let's look at some more examples of that. So like the square root of 63 is actually 63 to the half power. The square root of 19 is 19 to the half power. Those are all equivalent and different ways to write it. So the cube, or third root, is 1/3 of the power. So notice what's happening here. So the cube root is 1/3 of the base number. So way back over here, so we were asking ourselves, what's the cube root of 8? What times what times what gets me 8? Well, the answer is 2. Well, I could also write it this way, 8 to the third power. That's asking me, what is the cube root? And that is 2. So 8 to the 1/3 power is 2. Part of it you can keep an eye on is the fraction exponent here is making my number smaller, is really what it's doing. So let's look at another example of that. So write the fourth root, okay? So I'm looking for the fourth root of 81, which is 81 to the 1/4 power, the fourth root. So what times what times what times what gets me 81, and that ends up being 3. So I want to help you out, just kind of manage this stuff. You can pause it and look through these two things, just follow them through as a proof of why this works, how these things cancel out. But what I really like is when it comes back down to here, just this guy right here. It'll help you keep track of what's going on. The top number is the power, and the lower number ends up being the root number that you're looking for. So, for example, 13 to the 3/4 power. Now, this is the root, so it's 13 to the third, and the 4 ends up being my index out here. So 13 to the 3/4 power is saying the fourth root of 13 cubed. Okay, just something to keep practicing, keep wrapping yourself around. So 17 to the 307ths. Okay, so this is the power. So it's 17 to the third. And then right here ends up being my index. So it's my root. Okay, so it's the 7th root of 17 to the third power. Yeah, I know that's a mouthful, but it's some things that I want you to keep an eye on. You want to keep an eye on that in these exponents. Some of the exponents could be a fraction, and you want to be paying attention to what that fraction is meaning. So let's try a couple things here. Now, the big thing is keep in mind, so 81 to the 1/4 power. So this is your power. So it's 81 to the first power. And this guy right here is your root. So it's the 4th root of 81 to the first power. So I'm asking myself, what times what times what times what will get me 81? What times what times what times what will get me that 81? And the answer is 3. Okay, I want you to try with a couple of these. I have some nice numbers here to work with. All right, press pause and you give it a try. All right. The quad root of 16 is 2, the cube root of 27 is 3, and the square root of 64 is 8. Now notice I didn't put a 2 here, because we usually don't write that. Certainly there, you could put a 2 there, but eventually you're not going to want to do that, because that's not a notation we have. Okay, so we're going to verify that these thing equals 3 to the 64 to the third 3/2 power. I'm going to go ahead and use a formula that I saw, or a rule we recognize that if they have the same base, you can add the exponents. So we end up with 64 to the 3/2 power. Now let's go ahead and turn this into something crazy here. So this is my power. So it's 64 to the third power. And then this is my index. So it's telling me that it is squared. So I'm looking for the square root of 64 to the third power. And I could keep going, find 64 to the third power and do the square root on that one. But this is what I want you to figure out. Oh, hello. We have a cat growing out of a flower pot. Hey, that kind of looks like my cousin. Or at least it reminds me of him.